Hello friends, I welcome you in lecture number 18 on hypothesis testing. In this lecture, we are going to discuss one more example on large sample test for a population proportion. So let's see what this example is telling us, or what is the information given in this example. 40 people were attacked by a certain disease and only 36 survived. Will you reject the hypothesis that the survival rate if attacked by this disease is 85% in favor of the hypothesis that it is more at 5% level? So here we can see that we are given the information of people who survived after attack by certain disease, and they are making this statement here: will you reject the hypothesis that the survival rate is 85% in favor of the hypothesis that it is more at 5% level? So they consider this population proportion. Okay, they consider that population proportion is 85%, that is small p is 0.85. They are making this hypothesis and they ask us to check whether we will reject this hypothesis that the survival rate is 0.85 in favor of the hypothesis that it is more at 5% level. So this is going to be alternative hypothesis and this is going to be null hypothesis. That will you reject the hypothesis that survival rate is 85%, that is null hypothesis is population proportion is 0.85, in favor of the hypothesis that it is more, that is population proportion is bigger than 0.85. And to test this null hypothesis, they have given the data. They are considering a sample of 40 people and they find that there are 36 people who survived after attack by this disease. So the sample size is given as n equal to 40 and capital X, which is the number of people who survived after attack by that disease, is given as 36, and level of significance is 5%, that is we consider alpha equal to 0.05. This is given information, and using this information we will answer this question that will you reject the hypothesis that survival rate is 85% or it is more at 5% level of significance. So as usual, first step is to decide null and alternative hypothesis. So equality part always goes in null hypothesis. So we consider that null hypothesis is population proportion is 85% and alternative hypothesis is that population proportion is more than 85%, that is p is greater than 0.85, and we assume that null hypothesis is true, and we test this null hypothesis using one sample z test for population proportion. And because we have strictly greater than sign here, this is upper tailed test or right tailed test. So we have to consider the area in the right tail as 0.05. Level of significance is 0.05. Now to apply one sample z test, first we have to check whether that condition is satisfied or not. We require that n times population proportion and n times 1 minus population proportion both are greater than 5 to apply one sample z test for population proportion. So let me calculate these two quantities. N times p, value of n is 40, population proportion is 0.85, and this product is 34, obviously greater than 5. N times 1 minus p, that is 40 times 1 minus 0.85, that is 0.15, and this becomes 6. So both are greater than 5. Therefore we can apply one sample Z test for population proportion. One sample Z test for population proportion. So this we should check so that we are clear that whether this test is applicable or not. And now we are familiar with the formula of test statistic for one sample Z test for population proportion. So what is test statistic for this case? Capital Z equal to sample proportion P hat minus population proportion denoted by small p divided by square root of population proportion times 1 minus population proportion divided by n, where this p hat is sample proportion, and that we can obtain by this formula. Sample proportion means total number of people in this sample, and here I have to consider number of people who survived after attack by that disease, that is capital X divided by n. If you wish, you can first write down the formula. P hat is capital X by n, that is 36 divided by 40, and this turns out to be 0.9. So now we have P hat equal to 0.9. We assume that null hypothesis is true. Therefore small p is 0.85 and value of small n is 40. So we substitute all those things in this formula of test statistic. So here I write that P hat is 0.9, population proportion is 0.85, square root of population proportion, which is 0.85, 1 minus population proportion, which is 0.15, divided by n equal to 40, and therefore capital Z, this is equal to, the difference in the numerator is 0.05, and using scientific calculator I find that this square root becomes 0.05646, and this division is 0.88558. I have fixed my calculator up to 5 decimal places, and if we round off up to 2 decimal places, then we have 0.88. Therefore calculated value of Z statistic up to 2 decimal places is 0.88. Now once we calculate test statistic, we have to find out the critical values for given distribution Z. Here this test statistic is approximately a standard normal random variable because these two conditions are satisfied. So now we find out critical values. For that we roughly sketch the graph of standard normal random variable. It is approximately a bell-shaped curve. We are familiar that normal distribution has this bell-shaped curve, and this is this center. Here value of small z is 0, and because we are given upper tailed test, we consider area in the upper tail or right tail, and the level of significance is 0.05. Therefore this point is denoted by z suffix 0.05. So we are interested in this value of z, which is known as critical value, and for that we will use cumulative probability table for this standard normal distribution. Now from this we can say that area to the right side of this point is 0.05. Therefore area to the left side is 0.95. So I can say that probability that capital Z is to the left side of Z0.05 is 0.95. So using cumulative probability table, I have to decide this value of Z such that this area to the left side of this point is 0.95. So now we check in the table. We have to search for 0.95 area. All these values are cumulative probabilities, and we are interested in the cumulative probability of 0.95. So I have to search for 0.95 area in this table. So let me search for 0.95. Here I have 0.9515. This is 0.9505, near to 0.95, and this is also near to 0.95. If we round up these two values up to 2 decimal places, we will obtain 0.95. So what we can do is we can find out the values of Z corresponding to both of these values, and then we will take their average. Here this corresponds to 1.6, and what about these two? This corresponds to 0.04. So the value of Z corresponding to 0.9495 is 1.6 plus 0.04, that is 1.64. Similarly, this is corresponding to 0.05. So the value of Z corresponding to this value is 1.6 plus 0.05, that is 1.65 divided by 2. So this is 1.645, and this we consider as Z suffix 0.05. So the value of Z for which this area to the left of this point is 0.95 is 1.645. So here I can write that from the table we find that Z suffix 0.05 is average of 1.64 and 1.65, and therefore this value Z suffix 0.05 is 1.645. This is the critical value for our problem. This value is 1.645, and the area to the left side of this value is rejection region. This is our rejection region. This is non-rejection region. Now we compare the calculated value of test statistic, which is 0.88, with this value. So 0.88 is less than this 1.645. So it might be somewhere here. We can say that this is the calculated value of test statistic 0.88. This means we are in the non-rejection region. So we fail to reject null hypothesis. We can write that since capital Z, which is 0.88, is less than this critical value Z suffix 0.05, which is 1.645, we fail to reject the null hypothesis H0. Null hypothesis cannot be rejected. And what is null hypothesis? Null hypothesis is that population proportion is 0.85, that is the survival rate is 85%. We cannot reject this claim. So the final conclusion can be written as there is no evidence to reject that population proportion or survival rate is 85%. This is our conclusion. Therefore, we can say that there is no evidence to reject that the survival rate is 85%. We fail to reject null hypothesis. Null hypothesis is that population proportion is 0.85. So we fail to reject this statement. That means we cannot, we have no evidence to reject that the survival rate is 85%. So this is nice problem. All you have to remember is this formula for test statistic, and you must be familiar with all these terms: population proportion, sample proportion, capital X. You must be familiar with all this terminology, and the remaining procedure for hypothesis testing is same from lecture number 1 to all the lectures which we have discussed and which we are going to discuss. The main procedure for hypothesis testing remains same, that we start with stating null and alternative hypothesis, then we check what is level of significance, then we write down the formula for test statistic and we calculate value of test statistic. After that, depending upon the distribution of test statistic, we decide the critical values, and then we compare calculated value of test statistic with critical values, and we check whether we are in rejection region or non-rejection region. So almost the procedure is same, but the only difference is the formula for test statistic and whatever the distribution is there. So far we are using Z test, and we have used T test. We have used only two distributions, standard normal distribution and that T distribution only. So almost all the process is same. All you have to remember is different formulas for test statistic in different scenarios. First we have seen a large sample test for a population mean, then we have seen small sample test for a population mean, then we have seen the large and small sample test for the difference between two population means. Now we are discussing large sample test for a population proportion, and after this we will discuss large sample test for the difference of two population proportions. So you can easily understand if you are familiar with underlying terminology. All you have to understand is what is the underlying concepts for all this process. If you understand the concepts clearly, then almost 90% process is same for all types of tests of hypothesis testing. So this is all about this session. I hope you like it. Thanks for